The chorus effect takes a signal, delays it slightly, then modulates the delay time up and down. This modulated signal is mixed with the original to create movement and interest in a sound. Here I'll use the Air Music Tech Chorus plugin, which is simple to use and very effective. In this exploration, I'll use a simple 220 Hz sine wave and an electroacoustic guitar to examine the effects of the controls, and I'll take the settings to their extreme values to examine the range of sound textures that are possible, many of which would not be useful musically, but could be used for special effects. As chorus is often best used as a stereo effect, I'll use a file that has the same sine wave signal on both channels as the source. In this demonstration, I'll use a vectorscope as a visual aid to be able to see the stereo effect of the chorus as well as hear it. Here's the sine wave with the chorus plugin bypassed. Notice that in the vectorscope, the trace is a vertical straight line. This shows that the signal, being the same on both channels, is mono. Muting the right channel so that the signal is only on the left does this. Muting the left channel so that the signal is only on the right does this. The upper quadrant of the vectorscope between L and R and the mirror image lower quadrant represent signals that are mono or stereo. If the trace extends to the plus S or minus S quadrants, then it contains information that is out of phase. If the trace is a horizontal line between plus S and minus S, then it is completely out of phase. Let's start with the controls at their default settings, which clearly Air Music Tech believes to be a generally useful starting point, with the exception that I'll set the depth to 0 so that there is no delay and therefore no chorus effect. I'll then gradually raise the depth from 0 to maximum, then return to a setting that would commonly be useful. The calibration of depth in milliseconds, by the way, refers to the maximum delay time. What we can notice is that at first, the tips of the vectorscope trace stay within the boundaries of left and right, but at a certain point they stray into the out of phase quadrants. Let's see that again. Here is the point where the tips of the trace just touch the edges of the stereo zone, which in this example, for a 220 Hz sine wave, is a depth, a maximum delay, of 0.81 milliseconds. This is interesting and also of relevance because audio that contains out-of-phase information can cause problems for monocompatibility, and is something that a wise engineer will always check. To continue, I'll reset the depth to its default starting point. Next, I'll sweep the rate control through its range of settings. Clearly, there's a range of rates that would potentially be musically useful, and higher rates might be useful for special effects, particularly science fiction sound effects. It's worth bearing in mind that it is widely considered that vibrato in singing should have a rate around 6 Hz. This doesn't mean that you have to set the chorus rate to 6 Hz, which in this example is too high to sound musical, but it's always worth having a reference point in mind when making artistic decisions. To continue, I'll set the controls back to their defaults. Pre-delay is an overall delay that is applied to the modulated signal. Again, I'll sweep the control through its range of settings. This has less of an effect on a sine wave signal than a real-world music signal, so I'll apply it to a recording of electroacoustic guitar, which is a good source for demonstrating any type of time modulation effect. As you can hear if you listen closely, the sound gets richer with longer pre-delay times, and there is probably a point at which the degree of richness is optimum. This will vary according to the instrument or vocal that you're chorusing. LFO, low frequency oscillator, LR phase, represents the relative phase of the modulating signal in the left and right channels. If the phase is set to 0, then both channels are in step, and the result is mono. The overall level modulates, but there's no stereo image shift. If the phase is set to plus 180 degrees or minus 180 degrees, then when the left channel is at, for instance, 3 milliseconds of delay, the right channel is advanced with respect to the input signal by the same amount, 3 milliseconds. This will create a stereo image that swings widely between left and right. The default setting in this plugin is plus 90 degrees, which sounds subjectively the same as minus 90 degrees. The 90-degree relationship, sometimes known as quadrature, places the modulating signals in the left and right channels 1/4 of a wavelength out of step, which seems to be a good starting point for chorusing, although all options should be explored. LFO waveform offers the choice of sine or triangle wave. There's a very subtle difference between the two. The triangle wave, other than going back and forth, has a constant rate of change. The rate of change of the sine wave varies throughout its cycle. The sine wave, therefore, sounds more swirly than the triangle, both in the subjective texture of the sound and in the pan of the signal. I'll demonstrate this using both the sine wave and electroacoustic guitar. The feedback control will work on the sine wave, but other than for science fiction effects, which I'll come to later, does not provide a useful demonstration. So the electroacoustic guitar in this case is better source material. The feedback control works very much in combination with pre-delay, so I'll step through a range of combinations of settings, some of which will work musically better than others. finally, the mix control. Normally, in any plugin, the mix controls the amount of effect you want to hear. But in the case of chorus, it can dramatically change the sound texture. Here's a sweep of the mix control on electroacoustic guitar with otherwise default settings. It's pretty much an amount control, but here it is with a high level of feedback. As mentioned earlier, this chorus plugin is capable of a useful range of sci-fi oriented sound effects. Here are a few. Effects can get weirder when the controls are in motion. Here are a few demonstrations. In summary, the chorus effect can be both musically useful and capable of creating interesting sound textures. These demonstrations have only scratched the surface of the possibilities. I'm David Meller, Course Director of Audio Masterclass. Thank you for listening.